Well, Wes, I see that you want to talk a little bit about Veritas Volume Manager and a specific feature of Veritas Volume Manager, which is called dirty region logging. What can you tell us about it?
Well, I can tell you how it works.
Great. Well, let's find out.
All right. So one of the features of Veritas Volume Manager is dirty region logging that can be added to mirrored volumes only. And it's there to help in crash recovery after a system failure. Now, before we get into that, let's talk about what the problem is that this is solving. One is the way we write to a mirror, it's called true mirroring. We basically have an I/O process come in, and we have a process called VXIO that duplicates that and writes it to each plex independently. Each plex must complete that write, respond back to the VXIO driver for both of them before it returns a write acknowledgement back to the originating application. So in this case, any writes that are occurring in these plexes are not exactly being updated at the same time. So while writes are occurring, both plexes are in flux, they're not exactly in sync. So when we shut down a volume, they complete the writes and everything is in sync. But if a system crashes, then they will be out of sync, so upon recovery, Volume Manager will initiate a resynchronization. The idea is to get every single bit in each plex to be exactly the same, a perfect mirror. So it runs through this synchronization process. It's a lot of extra IOs, bigger impact on your system during those IO operations, and it also is time consuming. So the larger the volume, the longer it takes to resynchronize. So dirty region logging brings to the table a way to reduce the amount of synchronization that has to occur. So what we're going to get is a bitmap log that actually is associated to the volume in an extra plex called log plex that's going to track regions of space in here. So let me kind of get rid of this here and that. And we'll split this up into different regions. And a region of space consists of the same data, same disk blocks in both plexes. And each one of these regions will have an associated bit in the bitmap for this. So if there's data in flux, meaning there's writes going on in a particular region, like I have writes going on in here, maybe writes going here, and writes up here or something, then each one of those regions will be marked with a 1. Any region that doesn't have write activity going on, which is static, both sides are exactly the same, will be marked with a 0. So in the event of a crash, when we come back up and perform a recovery, what we're going to do is read this map, and there's a little extra going on because it takes the map, ORs it against itself, drops the bits out that show the regions that are marked dirty, and then it only synchronizes those particular regions. All regions that are not marked dirty don't have to be synchronized. Thus, we are going to get faster recovery, faster synchronization, reduce the amount of IOs it takes to bring this back up to par, and there we go. That's what dirty region logging does. Doesn't do anything else. If you have a disk failure, dirty region logging does not come into play. It only comes into play after a system crash, and again, only for mirrored volumes.
So really, these bits here can be going 0, 1, 0, 1, depending upon the state of the plexes. Is that right?
Well, not exactly.
Not completely?
See, it sets to 1 prior to a write occurring in that region, the first write. But it's actually, you can have up to 2,048 regions, and they go by least written, which means once 2,048 regions have been allocated as dirty, then the least one that's been written to gets cleared.
Got it. Okay, great. Well, Wes, thanks for taking us through what dirty region logging is.
My pleasure.